As per Albert Einstein, regardless of how far our telescopes go, we won't ever see the beginning of the universe. However, the James Webb Space Telescope's most recent discovery has captured a surprising phenomenon that may be related to the Big Bang. It appears that Einstein was correct when he stated that the Big Bang is elusive. Given that the beginning of everything takes place in darkness and is so vast that it defies our physical awareness, we might wonder if we could ever truly witness it. This groundbreaking discovery may shed light on the events of the early universe and provide crucial explanations for our existence. The universe we know today was thrown out of balance around 13.8 billion years ago when it was just a small point. Amazingly, the remnants of this initial state are still present in the universe's black holes, where gravity approaches infinity and makes it difficult to measure things. The James Webb Space Telescope, NASA's freshest space observatory, has caught pictures of a dark opening and a supermassive void from the earliest days of recorded history, conceivably even before the main stars showed up. Imagine the early universe shortly after the Big Bang. A flaming, dense mix of radiation and particles expanding at incredible rates. At first, light, as far as we might be concerned, didn't exist since photons were continually connecting with free protons and electrons and couldn't travel uninhibitedly. The universe took about 380,000 years to cool down enough to allow the first neutral atoms, mostly hydrogen and helium, to form. When the universe cooled adequately, photons could move uninhibitedly, making the microwave foundation. Be that as it may, the universe stayed dim because of the shortfall of light sources like stars and systems. Reionization began hundreds of millions of years after the Big Bang, resulting in the first stars and galaxies being formed. The hydrogen atoms surrounding these young, hot stars were ionized by ultraviolet radiation, allowing both visible and ultraviolet light to penetrate. Gravity assumed a critical part in making the principal stars and worlds, compelling billows of gas, fundamentally hydrogen and helium, to cool. In these thick districts, strain and temperature climbed to where atomic combination touched off in the centers of the main stars, illuminating the universe interestingly. The radiation from these stars and cosmic systems ionized the thick cloud of nonpartisan hydrogen that covered the universe around then. The end of the Dark Ages and the beginning of the universe as we know it marked the conclusion of this process and the ionization of the entire intergalactic medium. Even with the most advanced telescopes, we still have a limited view of the universe. Scientists had previously assumed that this turning point occurred around 380,000 years after the Big Bang. The James Webb Space Telescope, which is known for its advanced capabilities, is on a mission to discover the mysteries surrounding the origins of the universe. The James Webb Space Telescope, with its 16 honeycomb-shaped mirrors and cutting-edge infrared technology, records light signals that have been with us for approximately 13.5 billion years. It has previously taken huge steps, finding old cosmic systems and uncovering a dark opening that existed only 500 million years after the enormous detonation. Dark openings are basically fixes of enormous void. However, their phenomenal gravity permits them to draw in encompassing matter. This black hole, which weighs 10 million times as much as our Sun, challenges our understanding of the world in its earliest stages. Researchers make sense of its size by proposing that dim matter, or the interaction by which dark openings amass matter, builds their mass. Researchers are baffled by the discovery of a black hole that appears to be older than the universe as it expands at such a rapid rate. These early universe black holes appear to have characteristics that are distinct from those that we have studied. The series of discoveries made by the James Webb Space Telescope have shaken up established theories and exposed holes in our understanding of the universe. In galaxies that appear to have existed long before the universe itself, massive black holes are expanding at a rate never before seen. Rethinking our perspective on the world presents a challenge for scientists. Existing theories are being revised, as are new ones. For instance, the hypothesis of differential actual factors recommends that the regulations administering the universe were different at its start. The rapid expansion of galaxies and black holes could be explained by these changes. By investigating the behavior of small particles and the forces that were acting on them in the early universe, the theory of gravity aims to combine Einstein's ideas with those of quantum mechanics. The Big Bang and the early evolution of the universe are both explained by Einstein's theory, but recent observations cast doubt on some of these hypotheses. Researchers are confronting a mind-boggling puzzle, as George Lemaitre initially alluded to as the principal nuclear speculation. Edwin Hubble's observations at the end of the 1920s revealed that distant galaxies are moving away from us, indicating the expansion of the universe. New speculations have been integrated to make sense of these perceptions. Different speculations about the development of the main dark openings are being scrutinized. One hypothesis proposes that they framed from the leftovers of gigantic, brief populous 3 stars, which could have taken their lives in cosmic explosion blasts, abandoning dark openings. There is a mystery surrounding observations of supermassive black holes in the early universe, which range in mass from millions to billions of times that of the Sun. How these black holes grew so large in such a short amount of time is a mystery to scientists. Under certain conditions, according to one theory, black holes could form before the first stars, possibly through the direct accumulation of matter or the merger of smaller black holes. The James Webb Space Telescope, with its amazing capacities, is set to uncover more about the early universe than any past telescope. As a sort of time machine, we can see the first galaxies and quasar black holes by looking deep into space. This telescope will assist us with investigating the secrets of the early universe and push the limits of how we might interpret reality. Dark energy, a mysterious force that is driving the accelerated expansion of the universe, is also being studied by scientists as they delve deeper into the early stages of the universe. Dark energy's true nature remains one of cosmology's greatest mysteries, despite the fact that it is estimated to make up 68% of the universe. Because it has an impact on the rate at which the universe expands and may have significant implications for our comprehension of the cosmos, it is essential to comprehend dark energy. Also, researchers are looking at the multiverse hypothesis, which recommends that our universe is only one of numerous universes existing all the while. Our investigation of the universe is further complicated by this theory, which is based on some interpretations of quantum mechanics and the evolution of the universe.